Knowledge Bolide, January 5th, take one.
Yes.
Take two. Hello, everyone, and welcome. It is Wednesday, the 5th of January, 2022. Welcome to the new year. We are meeting with the Knowledge Bolide crew as usual, and today we're going to be discussing Mesosiderites. These are a really unique meteorite that are, we're not going to spoil anything, but they're very unique, very rare. They contain half metal, half silicates, and Mike Kelly is going to give us our deep dive into that today. Before we get into Mesosiderites, I figured I'd open it up for a little bit of show and tell. If anyone has anything to show off, I see Mike Kelly with his hand up. Hello, Mike.
So for the first time last week, I finally missed a hangout. And I was coming back from holiday break. So I just wanted to go ahead and show you a couple of the Christmas presents.
Oh, nice.
So that's a Chondrite ungrouped 1500. So that's a relatively early NWA number. Back when the Chondrite ungroups were below 100, which they're over 100 now. And this is a pretty cool meteorite that's it's braconite-like in its composition, but its O-isotopic ratio puts it outside the normal braconite range. So that was a cool little piece I picked up when I happened to be in Texas. So I was able to go visit Mendy.
Oh, fantastic!
While sitting down and visiting with Mendy, I was able to go ahead and bring home a little souvenir from his new place. Waiting in the mail for me when I got back was this. Thank you, Topher.
You're welcome, buddy.
So little Munio dog tag, which when I finally get a curio for all my pieces, that'll be what I'm hanging the keys off of.
Oh, nice.
Awesome.
Well played.
And then the final piece I got, being a subtype collector who hasn't gotten a subtype in a while, kind of been off focus, went ahead and picked up a piece of chain par, which is from India. So this is an LL subtype 3.4. I think there, if the memory serves me correct, I think there's 28 total of those. And then you subtract out the Antarctics, and there aren't a whole bunch of these available. And this was a relatively large multi-kilo sized size fall. So it was decent amount of material out there, but it's not in too many people's collections as posted on Metpol photos.
Yeah,
I
didn't recognize the name at all.
Yeah, it's kind of an obscure one to me. So it's pretty old, and this is a piece. It's obviously got an old Steve McLean style label to it.
Mm-hmm.
So this was a great snag from Terry Hinson from the Steve McLean collection.
Fantastic, man. So you got a subtype, another subtype in your collection, and it's actually not it's a subgram, but not sub-subgram.
Yeah, and there's two pieces there, so I'm thinking one piece will probably end up mounted up to a microscope slide at some point and turn into a thin section.
Oh, sweet.
And then I'll have the other piece for a good visual. Which this gets me down to only needing one LL left. So.
And which one is that?
Yeah,
LL
what's that?
3.5, I believe, is the last one I need of the LLs.
Wow. Yeah. So that is really fantastic. And another example of a collector who hones in their collecting to certain things rather than just, oh, I gotta have it. Hey, Art. Good afternoon. How are you, buddy?
Oh, okay. I got a interesting one here called Ozerki. It's got some nice crust on it. It's also got some slick and slide on it. There are some shiny areas with striations. That makes it interesting in itself. I don't know of too many meteorites that exhibit slick and slides. 33.99 grams, and it's an L6 chondrite with
Ozerki is going to be a weathering 0 because it was a witness fall in Russia. So
yes.
And how about the backside? Now let's see if she's got a bud on her.
Okay.
Yeah, look at that slickenside just sticking out there. Yeah, thank you very much. That is a beautiful meteorite. Ozerki is one of my Ozerki and Chelyabinsk are some of my favorite ones. And that's a really good example. And you're right, it does have really nice slickensides. And we talked about slickensides last week. And if you look back on last week's video, it was the holiday edition, you'll see a really good in-depth scientific discussion of slickensides. And that was a great example because we mentioned that they're often shiny and we didn't show any shiny ones. So Art, thank you. It's one of my favorites, like I said, and I'm partial to Witness Falls. That's my weak spot. So
Right.
We do have one for sale.
That is my business partner, Miss Sue Spinnato, my lovely wife. So yeah, I'll let her sell, and I'll just keep the conversation going. Hey, Pat, my man, what do you have there?
So this one is top secret. So this one, this particular meteorite is a sample that I have some amount of this on the way from Africa, so that's why it's still top secret. But it's type 3 of some sort. This is another slice of the same one.
Oh, it's gorgeous.
Yeah, at about 230, there's a carbonaceous inclusion there.
Mm-hmm.
And if you look carefully, that carbonaceous inclusion has chondrules in it. That's
a rarity.
Yeah.
Then there's the chunk of cinnamon on the bottom.
Yeah, this one has this rock has some brecciation possibility too.
Can you explain what brecciation is, please?
Brecciation is when you have multiple types of rocks that have all kind of been crammed together into one bigger rock. And so there's lunar breccias, there's impact melt breccias, but it basically just means multiple types of stuff all crammed together. Right. And this one doesn't show it super well, but this is my sole classification so far. But this one has the chondrule cluster sort of texture in some areas here, where the chondrules were still molten, or still plastic. We call it in material science sort of terms. And as the rock was accreting, and that resulted in the chondrules kind of smushed with each other to, instead of being spherical, they're smushed together. And so that is called cluster chondrule texture, or sometimes cluster chondrule fabric. This one's one of my favorites. This is Schun's NWA 13909. This is a really nice LL 3.15. So fairly primitive. And speaking of brecciation, Rimarudi's almost always show brecciation, and that particular one doesn't. This is another just meteorite. That one at about 130 has a really nice, very green chunk of olivine that's just kind of floating in there amongst the chondrules and busted up chondrules. This one is NWA 8007.
Man, these are all beautiful slices. All of them showed distinct characters in all the chondrules, whether they're bleach chondrules or compound chondrules. And then the chondrules in the carbonaceous class.
Yeah, this is basically chondrule eye candy.
Mm-hmm.
This is the one that Chris Monk cut up and sold. Very beautiful meteorite with some very photogenic chondrules in it. Mm-hmm. This is just begging to be made into a thin section. Yeah, so let's flip this guy over real quick and look at the flip side of him. This guy's got some nice larger chondrules. See this red chondrule there, or it may actually be a CAI, because there are red spinel CAIs. But so that's the Metcam 2.0, and she will be going to Tucson with me.
I look forward to Tucson. We are just less than 3 weeks away from it, and it is going to be absolutely immersive. We're going to even more than usual, I'm going to live and breathe meteorites. So 2 years ago in Tucson, I put a box of my purchases away for a rainy day. And I opened them up this weekend and took a few out. So take a look at this Seymchan 15 gram palisite. It is just redonkulously gorgeous.
Oh, yeah. Yeah.
Yeah.
I usually like the etched ones. You can see my dirty fingerprints. I usually like the etched ones, but somehow, for some reason, this one double polished really catches my eye.
Mm-hmm.
Yeah, that's a pretty one.
And it's super translucent too.
Backlit, that would look really nice.
Yeah. Frontlit doesn't look bad either.
No, that's true.
Yeah. And then here's another Seymchan that I pulled out of my rainy day stock that I thought was really interesting. And it reminded me of a piece of Seracho that Mike Kelly brought up one time.
Oh, yeah.
How it has that metal off to the side.
And a beautiful etch.
Yeah. This one, the etch is working for it, but the metal is what really catches my eye all over to one side. Just gorgeous. Yeah. So this is a palisite Seymchan from Russia. So like I said, it is 2022 already, and this is our 86th in a row. This may be the last time in a little while we get Marco Gaisser to be able to join us live from Germany. The time difference is just too much for him. He's too busy of a man to join us normally. But he put a little video together that he's going to offer some commentary on, and we can openly discuss. This is his astrophotography highlights of 2021. Okay.
Hello, everyone. First of all, Happy New Year.
Happy New Year, buddy.
Happy New Year to you.
Hey, Marco.
Yeah, I wanted to show some of my highlights of 2021 of my astrophotography. And the first one is Messier 78. It's a reflection nebula. And I captured it in wide field, so it's not only in Messier 78, but also a very nice part, so-called Barnard's Loop. That's the reddish one that you can see here.
Wow.
That's an emission nebula, and that's an absolutely wonderful region on the sky. Beautiful.
That is absolutely just amazing.
Yeah, on the lower right corner, you can see Messier 78. So a dark nebula and a reflection nebula. And this reddish one is Barnard's Loop. And this is an emission nebula. So a hydrogen gas that emits that reddish light.
Could you see this item right here?
Yeah.
How it looks like it's like spewing stuff. Is that just my imagination?
That's also a reflection nebula. You can see that star. And the light of that star gets reflected in that dust region, or in that cosmic dust, and then you can see that bright white areas around that star.
That's super cool.
Beautiful.
Yeah, next one needs no explanation. The Big Orion Nebula, about 1,400 light years away in constellation Orion.
That is really good work, Marco.
Thanks a lot, Topher.
Wow.
Yeah, it's absolutely fantastic object out there. Also, emission nebula.
Oh, I was going to ask you a question on something like this. How long are you? We're looking at the end of a lot of work of a lucky night with clear skies. How many hours goes into capturing and processing and making available an image like this?
Yeah, so the longer you have, or the more data you have, so the longer exposure times you have, the better, because you can reduce noise out of that images, and then you can see all those faint details in the images. And what you can see here were about I think 2 hours of total capture, and then of course you need to process the data, and this takes, it depends, but at least I would say 3 hours to process the data, so that you can get such detailed image like here.
The blue part, that's called the Running Man Nebula. Can you see a running man there?
Exactly.
In the upper,
Up here? Yeah.
yeah, right there.
Yeah.
Do you see
the
it?
running man?
Oh yeah. Yeah. It actually looks like an Indian in headdress dancing around with like wings to me.
Exactly. The next one is the Rosette Nebula. It's far away, 4,900 light years in Monoceros, and it's a very big object. So you also need a wide field equipment to capture this. And yeah, here we are. It's an open star cluster with emission nebula, and yeah, absolutely gorgeous.
The colors are amazing. In the last one, we really saw the wisps of the blue. Now we're seeing deep reds and pinks. Just amazing.
Yeah. The reds that you can see is always ionized hydrogen, so hydrogen alpha. And you can also see different colors of the stars. So there are different spectral types of stars. You have very young stars. These are very hot stars, which show that bluish color. And the older stars are usually, yeah, more to the yellow or reddish side.
So this one right here is an older star?
Yeah.
That's amazing. Wow.
There's so many stars in that frame too.
Yeah, stars are really, really interesting. And the most interesting part is that everything that we knew about stars, we know from our sun. And here you can see the photosphere of our sun. And you see some sunspots, these dark regions. You see the granulation of the photosphere, so the convection of the gases and the plasma on the sun. And yeah, this is by far the easiest way to image and capture the sun. You need a special filter, you put it in front of your telescope, and yeah, then you can observe the photosphere.
Is this one up here, is this also a sunspot on the very top of the screen?
Yeah, exactly. Yeah,
and a sunspot's a cooler area, isn't it?
Mm-hmm. Exactly.
Okay.
Because it's about 1,000 degrees cooler than the surface. It depends, or it shows up that darker color. Nice. It's only about 1,000 degrees, and what are 1,000 degrees on the sun?
Yeah, what's 1,000 degrees? SPF 5 million.
Yeah, you only can see those sunspots on the sun, because all other stars are so far away that you can't see any details on those stars.
Oh, okay.
Yeah, the next one is here you can see my bigger telescope is a planetary nebula, the Dumbbell Nebula.
Gosh.
And these are very small objects, so you need a lot of focal length to capture them. And this is actually what happens with our sun in about 4 or 5 billion years, the end of a star.
You are serious about this. Your equipment is as serious as it gets, man. I'm impressed. and you know how to work it too.
Well, it's not James Webb, but
can you explain what we're about to see here?
Yeah, in June we had a partial solar eclipse, and what you can see here is the solar eclipse, and a lucky shot because I captured a plane crossing the eclipse.
Unbelievable, you lucky dog. Were you just rolling around with laughter when you caught it, or what?
Absolutely, I couldn't believe it.
Whoa!
And it crashed into the moon.
Oh my gosh.
If you see or have a look on the silhouette of the moon, you can see the mountains and the valleys of the moon. Do you see that?
Yeah,
it's not the flat surface,
it's not a sharp dissecting line. Yeah. You can see the topography of it.
That's something that I think it's really fascinating.
Dude,
yeah,
unbelievable shot right there. Look at you crazy German buddy. I can't believe
you. Yeah, one of my highlights this year was the new telescope. It's a dedicated solar telescope, which makes possible to observe the sun's chromosphere with all its details. So all those very nice prominences and the chromospheric network, filaments, and so on. Yeah, you need a special equipment to visualize those features. Yeah, now I have the possibility, and it's really a fascinating and a great part of the astronomy.
These
The
are
cool thing
breathtaking.
about that hydrogen alpha scope is it's essentially a filter. You're only looking at light is between 400 nanometers and 700 nanometers. You're only looking at one line, 656.3 nanometers. That is it. Everything else is filtered out.
And only in this one wavelength you can see those features.
Yeah, only in that one way.
It looks so cool.
Thanks. Yeah, these are pictures which I took around the year, and yeah, you can see during hours how everything changes. That's incredible and not normal in astronomy.
Yeah, exactly. You don't normally get to see cosmic time unveil for you.
Yeah.
That's amazing.
Yeah.
Really cool.
Yeah, and you have the height of those prominences are about 5 to 8 times the diameter of the Earth. It's incredible.
I was about to ask you, can you give me some scale? Because I know that you can fit a bunch of Earths in the sun, but how big are those? Wow.
Are you talking about the things that are flaring up?
Yeah.
Oh my gosh.
Think about the sun is a small star, a very small star.
Fly me to the moon.
Fly me to the moon, and hey guys, we have stones from there.
Yeah, man.
What you can see here are the Apennine Mountains. This is the crater Copernicus, a very famous crater on the moon. And only to give you an idea, the diameter of that crater is about 95 kilometers, I think.
Huge.
And this is something.
Absolutely.
This is something that you notice in a lot of craters, and you capture them really brilliantly. Right in the very center, there's always a raised portion.
Yeah,
like that.
So the central mountains.
Yeah. Central mountain. Thank you.
They're in all the craters like that?
Most of them.
Wow.
A lot of
Yeah.
It's a rebound uplift.
Especially here on Copernicus, you can see very, very nice.
These pictures are so cool. Like the detail is crazy.
Thanks.
Yeah. Craters inside
this
a crater.
This is the South Pole region of the moon with the crater Clavius and Tycho. You have a very nice shadows here on the South Pole region and very nice contrast. This is the North Pole region with Zenus Iridum on the lower left corner of the image, and that crater on the upper right corner was Plato.
I want to bring something to your attention too, because there we go. Let me zoom in on this. Look at all these tiny little craters.
Yeah.
They're everywhere. That's unbelievable.
Yeah, and it's so great that you can capture these with an amateur telescope. So the techniques today are just incredible.
Man. You're blowing us away, buddy.
Oh, fabulous.
Yeah, now we're going deep into space. We'll have a look on NGC 7331 and Stephan's quintet. So yeah, I used the big telescope for this. Wow. These are all galaxies. And now here you can see on the lower left corner NGC 7331 with a distance of about 50 million light years. And on the upper right corner, it's Stephan's quintet with about 300 million light years. Absolutely incredible.
Yeah.
That is a screensaver if I've ever seen one. Wow. I love how the quintets interact with each other, and you can see them swirling with each other.
NGC 7331, look at the dust bands in that galaxy. And the background galaxies, of course. And this is 300 million light years away, Stephan's quintet. Captured from the backyard.
These galaxies are still in existence. It's not just the early light from them that we're now seeing.
Yeah, you have to think about when the light was emitted from those galaxies, the first plants grow here on Earth.
Yeah.
So
Wow.
are they actually as close to each other as they appear in the picture? Are they actually with each other?
Galaxy, I think on the right-hand side that you can see is about, I think, 60 million light years away. And the others are 300 million light years away. So they're not close to each other, but, or not all are close to each other.
Sure, thank you.
Wow. Marco, thank you so much for
You're
sharing
very
that with
welcome,
us. For not only taking those pictures and sitting out there and your patience and knowledge and expertise of running your equipment, but for sharing it with us and letting us do it as a premiere here tonight. I really appreciate it, man.
My pleasure.
Thank you. That was awesome.
Amazing.
Each week we try to learn a little bit about meteorites and fall in love and understand them a little bit better. So we have an ongoing mission to do that. And part of that is Meteorite 101. Mike Kelly has been teaching us about different types of meteorites over the past, it seems like a year. And we have the irons and carbonaceous coming up next on the agenda. But today we're going to be talking about Mesosiderites or Mesosiderites, however you just decide to pronounce them. But I wanted to show you where they are on our list, on our chart, and then turn it over to Mike Kelly. So we are talking about Mesosiderites, which are part of the stony iron group. And if you look at them, they are well on the temperature scale on the top. They are over there, and they represent a very small margin of meteorites. Yeah. All right, so Mike, the floor is all yours.
Okay, so as Topher briefly mentioned at the beginning, the Mesosiderites are a mixture of roughly 50% iron, nickel, metal, and silicates. They are the second type of stony iron meteorites. We already talked about the pallasites. And the prevailing thinking is that you get them by mixing liquid core material of an asteroid with solidified crustal material of an asteroid. Now, whether that's one asteroid and it gets disrupted and reaccreted, or it's two asteroids, there's a lot of different theories out there, and there's no solid consensus on exactly how it occurs. Because they're kind of an enigma, and we'll get into that a little bit later, because between the crust and the core of a meteorite is the mantle, and there's relatively little amount of mantle material in all these Mesosiderites. So where is that missing mantle? Yeah, so we've talked about good old Gustav Rose many times before. You can't do anything meteoritic without hitting Gustav Rose, it seems like.
I think you get paid for every time you mention his name.
I do not. These have been great, though, because I knew very little about Gustav Rose before I kind of got into doing a lot of this research. And he's a very fascinating character, and was, huge in the science we currently have for meteoritics. So in 1863, he divided the stony iron meteorites into those pallasites and the Mesosiderites. And so you can thank him for that class of meteorites. Mesosiderite is from two Greek words, meso, which means half, and siderite, which means stone. So half stone and obviously half iron. When Gustav Rose went ahead and broke this group out, he only had two meteorites to base it on, and that was Heinholz and Vaca Muerta. So not much. One fall and one find
Wow.
is what he broke them out on.
Wow, and he already knew that they were special. That's pretty cool.
Yeah.
And unique.
Yeah.
Mike, I just want to interject for 1 second. I don't want to mess up your flow, but this slide right here was new information for me. And I hope everyone digests this and learns this, because this is probably new information. Not to put too much pressure on you, but go ahead.
Sure. Yeah, no problem. So, we've covered a lot of the different chondrites, and so this is really interesting because kind of like the chondrites, you get a series of letters and numbers put together to give you the class and the petrology, but this is different. So the numbers used here are not the same as the numbers used for chondrites, where a 1 and a 2 would say you're aqueously altered, and a 3 through a 7 means you're almost no metamorphic alteration, all the way through severe metamorphic alteration. These letters that start out with tell you kind of what type of material the silicates are. So the A's are basaltic material, so that would be very, very superficial crustal material, right? As you move down, you get to the B's, which are a little more ultramafic. So ultramafic means you have those iron and magnesium contents is going up in the silicates. And then you get your C's, which are the orthoperoxenites. And again, so that would be a little deeper still within the crust. But again, like I said, what you're missing is where are those dunites, those really, really mafic rocks that would be the mantle material. And they're just, for the most part, missing. So there you got A, B's, and C's. And next to the A, B, and C, I kind of had it in there. You know, the breakdown as you get more ultramafic, you're going to get less plagioclase and more pyroxene. And as you get even deeper, you're going to get more orthopyroxene. So you can see the breakdown of how one replaces the other next to the letters, which is why I put that there. At the bottom, you have metamorphic grade in the form of texture. So again, your chondrites, your 3 through your 7 is metamorphic grade, but this is a little different because it doesn't start at 3 and then work both ways towards 1 and 2, and then also up towards 7. It starts at 1 and runs straight through to 4. So a 1 would be a fragmental matrix. So basically the silicates are broken up, but they're not overly heated. They're just kind of compacted together, and there's not much heating going on there. When you get to your 2s and your 3s, those are kind of a continuum. So we talk about igneous rocks on Earth, you know, having come from a melt and then recrystallization out of that melt. So a 2 has some recrystallization going on, so it's like a partial melt, and your 3s have you know, a high degree of recrystallization going on. So these are equivalent to like igneous textures in rocks. And then finally, 4, you have your melts, which are completely melted. So think about kind of the matrix that you see in an impact melt breccia. You know, they are completely cooked to the point of being very fine grained and melted.
Thank you so much, Mike. This is something that last 3 minutes I think is going to be replayed a few times, because this, I've never understood why a Mesosiderite was a B3. And now I at least have an idea, but not a full understanding.
So if you look at the slide I'm on right now, you're talking about the subtypes?
Yeah.
Yeah, the subtypes are there. Not every subtype exists. So if you look at this slide we're looking at now, the by the number slide, you know, there's 293 total Mesosiderites listed in METBOL. Of those, 222 were just given Mesosiderite. So some of that's the old stuff that, you know, the classification scheme for subtyping wasn't around yet, and they never got, you know, converted or further research done on them. But then in this breakdown chart I have here, you can see which ones are subtyped out. And so it's only, you know, what is that? That's 60 something of them, right?
Right.
And here's the breakdown of how many are in each of those classes. Or subclasses, I'm sorry. And as you can see, there are some that are kind of transitional. So like you have that one Mesosiderite down there towards the bottom of the first column, Estherville, where it's a 3/4, right? So it's got some aspect of it that was looked at and it was completely kind of a melty matrix, and other parts of it had a more crystalline matrix to it still with igneous texture left. So that's where you see those slashed ones. Those are line crossers. And one of the things that's neat about Mesosiderites is the subclassing is kind of hard from what I was reading, because they are breccias, like Topher mentioned. And one of the things about the breccias is they're kind of a continuous run of sizes all the way from the matrix up through the class, right? So it's hard to kind of say, hey, where does the matrix end and the class that you're seeing begins? And so it's kind of rough to say, okay, well, all of the matrix is melted per se, and then there's defined class and vice versa. They do their best to break them down, and that's the 3 silicate type breakdowns, followed by the metamorphic grades after there. There are resoundingly few falls. There's only 7 falls, and I got them listed down at the bottom there. And of those 7, you don't really see very many at all, except for the first one and Estherville. Lockwicks you could find every once in a while. The other ones I've you know, they're really, really, really rare on market. The missing palisite material, right? Oh, the missing mantle material that you would find in palisites. And so this is kind of interesting. how do you get a mixture of core material and crust material and almost completely exclude all that mantle? And again, looking at the metal in the Mesosiderites, one thing that they noticed is the metal is very homogeneous. So there's no real change in things like rare earth element composition between all the metal and all the Mesosiderites. And so that leads them to think that that metal was kind of all still in a liquid state, and it didn't kind of differentiate like a core of a asteroid would, given time to cool, you know, where you get differences in what the composition is. So they're thinking all liquid metal. The resounding theory is, you know, two bodies run into each other. Some of them do it kind of as a hit and run, where the one impacts, but then almost contributes not much material, somehow strips out chunks of the mantle, and they get excluded. And basically what happens is the liquid core material, because it comes in contact with the cool, liquid core material, because it comes in contact with the cool crust material, accretes to around that crustal material more than it would around the mantle material, right? Because the mantle is going to be hotter, it's deeper, it's closer to the core. So it's not really going to cause instantaneous quenching and bonding of the metal to the silicates, but it would with the crust. So the crust gets splashed with all this core metal. And the other thing that's interesting about the metal aspect is they know from the way it's formed and the structure that it initially cooled really quickly from high temperatures. And they're thinking that's because it was touching cold crust material. But then it has a really interesting aspect to it that it's the slowest cooling material that we've ever found out there from a geological standpoint. So something happened that caused it to retain its heat really well. And the theory on that is you're looking at a very large parent body, so 400 kilometers or more. And what they're thinking is after it disrupted, all of this mixed metal and crust then got deeply buried. And all that heavy overburden allowed the cooling rate to slow down drastically. So you initially cool really quickly, and then you have an incredibly slow annealing cool down at the end, which is kind of an interesting fact
Very
about
interesting.
Mesosiderites.
Yeah, that's very complex history. That's cool.
Yeah. And again, you know, how do you get rid of that mantle material? So some of the thinking is, you know, if it's a hit and run, maybe it doesn't, based on the material, right? So you're a deeper stony material, it's probably going to act in more of a plastic form. So whereas the crust breaks up into these little fragments we see in the Mesosiderites, potentially the mantle material forms larger chunks that have a harder time being reincorporated in reaccretion. So that's why they're not kind of mixed in there. Other theories that are out there are just that there's preferential survival of the stony iron Mesosiderite part we see. So that metal bonding all that crust together makes it more resilient, and it survives asteroidal impacts better. It survives travel through space with cosmic ray exposure better, and it survives going through Earth's atmosphere better. So we just happen to be that we find those pieces of that planetesimal, whereas we don't find those dunitic mantled chunks out there because they just don't survive. Again, you know, it's all theory. You know, there's different theories out there. You know, some have the liquid mantle coming from the impactor, some have it coming from the impactee. There's a bunch of different ways people rationalize it, along with, you know, is it a single event that creates Mesosiderites, or are they kind of created and then there's a second big impact that causes that burial we discussed that allowed them to cool so slowly. So yeah, it's very interesting and very big unknown as far as their creation, and also you know, where's this missing mantle. So we talked about the metal in the last slide. The other interesting thing is the silicates are also incredibly interesting that's inside the Mesosiderites. Oxygen isotopically, right, they are very similar to the Howardites and Eucrites from Flor Vesta. So some people postulate that Flor Vesta is actually the source, the parent body of the Mesosiderites also. And again, some of the thinking there is when Dawn flew by there, they had a really thick crust kind of on the south pole of Flor Vesta. So some are thinking, you know, there was an impact and a lot of the crust and some of that mantle got knocked off by one of those hit and runs where the metal got mixed with the silicates and ended up kind of on that bottom, underneath that bottom thick layer on Vesta. The metal itself, when you look at it compositionally, That's similar to the three AB irons. If you look at the Mesosiderites as a whole, the O isotopic puts it in the same area with the heads, which are postulated from 4 Vesta. Maybe it's 4 Vesta, maybe it's one of the other Vestian type asteroids. It's really neat to have 2 different materials, potentially from 2 different bodies mixed together to form a daughter body potentially, or a big faction of material that we really don't see with like the Dawn spacecraft going by 4 Vesta. You know, there was no smoking gun that said, oh, look, there's the Mesosiderite spectrum material there. So yeah, we talked about this for the most part. This is just some of those numbers. So when I was talking about the metal and the cooling rates, this actually has the metal cooling rates on there. So again, when it started out, it cooled very quickly, but then when it ended, it was less than 1,000 degrees K per million years. So that's incredibly slow cooling rates, like especially compared to like the cores of asteroids that we have in the form of core irons. Even they cooled a lot faster, and you figure they're buried they're buried under kilometers of material too. So it's pretty interesting. The other fun fact I had on here was down off South America, there's what's called the Altanian impact structure under the ocean. And this is the only deep sea crater structure that we know of that we have proof that it's tied to being meteoritic, and some of the kind of unaltered material they found in core drilling samples point towards it being from a Mesosiderite. That's right around the time that you had the Pliocene ice age switchover. So they were thinking, there's a couple papers out there that say, you know, the ice age was already kind of getting into gear, but an impact into the deep ocean would have kicked up enough material into the atmosphere that it probably could have been a contributing factor to tipping the scales and making that ice age really get into gear. So this was just a short list of some of the cool ones you can get that are out there, and some of the history behind them. So Bondoc is huge, 888.6 kilogram Mesosiderite, and it was procured by none other than Nininger.
Right.
So I guess the story goes he was down in the Philippines and he was looking through national mine assay material, you know, going through stuff that was supposedly iron ore, and found a chunk of material in there. To him, was very odd because it was iron with nickel content to it, and also silicates mixed in. So obviously that's an odd composition, and he backtracked it to where it was found at a mine claim from some senator's son, and was able to procure the Bondoc Mesosiderite, which is a huge Mesosiderite as far as I go.
And Mike, on the screen right now, I wanted to interject. This is my 3 personal pieces of Bondoc, and it represents the 3 different lithographies in Bondoc. On the top, you see the normal looking Mesosiderite 50-50 mix. In the middle, there is a pyroxene nodule, and then on the bottom is a complete iron nickel nodule, and it's etchable when they're that big.
So one of the things that's cool about the nodules is some of those are up to, you know, tens of centimeters across at a Bondoc.
That's huge.
And they get a lot of those interesting textures to them. And what you're actually seeing in Bondoc is that nodule is almost all camosite. It's got little bits of taenite and screbersite rims around the camosite. And then all those little specks in there, those are all oxide, silicate, and phosphate inclusions in there. So you're talking about, you know, those little specks are little bits of plagioclase, little bits of tritonite, whitlockite, chromite, things like that, and little bits of pyroxene all mixed in there. So that's why you get that characteristic look of the little silicate dots, you know, mixed in those bigger nodules. Vaca Muerta, you know, the dead cow, you know, it's a great name, obviously. I think they said most of the skeletons around there are potentially horse skeletons, but close enough, you know. Again, it was one of those first 2 meteorites that Rose went and looked at to birth the Mesosiderite class. It's very relatively available, which is why I added it on there. And it's got some really cool nodules because, like we said, there's those bits of silicate in there that tie in closely with the Howardites. and the eucrite material. So you can actually, if you're very lucky, find nodules of those silicates mixed in with the other pyroxene and every other little bit of thing from Vaca Muerta. And then finally, I got Estherville on the list because who doesn't like an American fall? Again, there's only 7 Mesosiderite falls total. It was relatively big. Again, I got it listed as the 3rd biggest at 320 kilograms on there. So again, that speaks to availability, but not to price.
Yeah.
And because it is a fall, you find pieces of it with phenomenal fusion crust on there, both on the normal kind of silicate metal blend pieces, and then there's also a lot of separated metal nodules, and those are kind of the harder to come by and more sought after bits of it.
Yeah, and those carry a premium, those little nodules.
Yeah.
Sure. Yeah. Awesome. Well, I really appreciate, Mike, every week your information. I do think it's worthy of telling the entire crew and everyone watching on YouTube that over the weekend I had a meteorite classifier call me up and we had a good conversation. He patted me and the crew on the back for what we do each and every week, education and entertainment. And he called out Mike Kelly by name, saying Mike Kelly is doing a fantastic job explaining the information and putting himself out there, explaining the information and getting it right. So thank you very much, Mike. People are taking notice of what you and we are doing here. Thank you.
Very nice. Thank you.
Appreciate it.
Good work, Mike.
Yeah.
Mike, yeah, you make it very accessible without like dumbing it down at all. Like you do wonderfully.
Jules, she shared this one with us, and hopefully she'll get off mute and join us. There she is. But I had to agree with her. As soon as I saw this, I was like, that's a piranha.
Yeah, this is my only Mesosiderite murdered that I own. It's NWA 12949. It's a find in 2019, 21.7 grams, did I say? To me, looking at it, it looks like an explosion between a silicated iron and a palisite, with lots of cool stuff in between.
Yes,
They are so complex and so beautiful, especially when you can understand a little bit of the science behind them. But I thought you did something, you submitted 2 pictures, and I thought it was really, really good because with Mesosiderites, a lot of the photography depends on the lighting.
Yes.
Yes.
So on this picture, you canceled out a lot of the reflections and you can really see the silicates in there.
Yeah, to me, it looks, like everything kind of smashed together and melted and, I don't know, cooled. And in the middle, it kind of, I don't know, it looks flowy like water, but it's not. I don't know how to explain it.
It is just absolutely complex beyond belief. This actually has some of the texture in the metal, if I'm seeing it right.
I really can't see anything in it. It's just like a little metal thread there.
Yeah, again, this is very magnified and blown up. Great photography. Look how in focus it is. But you can really see the silicates and all the metal and everything bunched up on this. We're 3 weeks away from the Meteorite Mansion, folks. So I just had to say that again. So thank you so much again, Mike and Jules, for that show and tell. I think we are now going to move into show and tell of Mesosiderites. We have 6 or 7 people with their hands up for Mesosiderite show and tell. Let's jump into it and speed roll it. We have Ron Metchis up first. Ooh.
This is a piece of Lamont. It's from Kansas. Another one of those rocks from Kansas. This is 158 grams.
Wow, it's big.
It's huge.
Yeah.
I got this from Blaine Reed in Denver a few years back. But yeah, I just fell in love with this piece as soon as I saw it. He had it displayed just like it is in this Riker box.
The name of it again, please?
Lamont.
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 It is very gorgeous. I love the metal. Looks like little flakes.
It is. It's little flecks of metal, and they're pretty homogeneous throughout the piece.
Next, we have Mr. Jim Shelton.
I have a piece of Mincy, Missouri.
Oh, wow.
A thick
It's
piece.
a thick one.
That's a brick.
This this was found in 1857, and this is the rarest meteorite from Missouri that I have in my collection. It's
Congrats.
35 grams, and it's still got some crust on it.
Oh yeah.
Yeah.
I love you can see the metal poking on the outside of the crust.
Yeah,
Absolutely.
and the backside,
Oh,
it's not polished, but there's a big olivine inclusion right there.
Wow.
that is super special.
That's Mincy. That's a hard one to get. There's a piece of this in the Vienna Museum, which is about 2 feet across. Amazing.
There you are. Hey, Bruce, how are you, buddy?
I'm doing okay. So I have a couple of Bondocs to show, but this is one of the iron nodules.
Oh, wow.
That's big.
Yeah.
Yeah, it's about 75 grams and about 40 centimeters across. Yeah, so
That's cool, Bruce.
Dude, cut it up, please.
what?
Cut it up, please.
No,
Please.
no, it's a complete nodule. I was like,
You're a complete
one of the things
nodule. Cut it up.
one of the things about Bondoc, I think that I don't know if Mike mentioned, it's like when they went to cut it, they cut it with regular water, and the whole thing like just kind of disintegrated.
Mm.
This is also
Ooh.
a silicated slice. You can see little bits of metal. And
Mm-hmm.
Wow. That is a big slice.
yeah, this is 128 grams.
Whoa.
Yeah, so about the size of my forehead.
Nice.
And the interesting thing about them is
Nice.
Nice.
Nininger, yeah, via aerolite.
That is super cool.
Beautiful.
Now we have Greg. Greg, how are you, bud?
Doing good.
Good deal.
I just have 3 Mesosiderites in my collection. I was surprised, only 3. This one is really impressive. Estherville 14.6. You got beautiful. Look at that.
Oh, I
That
love
beautiful
Estherville.
metal in there. And here's the other side. I got this from Dave New. This is from the Oscar Monning collection. Here's the label he gave.
Oh wow, that's
Amazing.
So this is really, it's really a beauty. And
That
then of
name
course,
is extremely important too, Oscar Monning.
oh really?
Oh yeah. Oscar Monning is a really important gentleman. I actually have his collection book right here. What's really good about this book is he was in depth conversation with Harvey Nininger. They wrote each other constantly. So every letter pretty much that they wrote each other is in here. And it is just an amazing book to see these two fine gentlemen dealing with each other. And then there's obviously a bunch of meteorite data in the back, including thin sections and pictures of the collection. But if you guys don't have this book, it's a very worthwhile book picking up. And I don't plug very many books. Now is the time on Sprockets when we go to Mike Kelly.
Of course, being a subtype person, you got to have some of the rare classes. So there's a Mesosiderite B2. That's 1912. So again, there's less than 10 of those.
Wow.
So it's got
wow.
A lot of metal in there.
metal there. Yeah, it's a very fine matrix.
That's beautiful.
Here's a specimen of an A3. I do believe there's like 6 of those total.
Oh.
So again, hard to come by ones. There's Estherville. It's not as impressive as that big old 14-gram nugget. Nice, slight, nice piece you had there. But yeah, this is a cool one if you're a collector of one of ones, because it is a one of. There's a NWA 10882, and that's a Mesosiderite A2. That one's a little smaller, not too much to look at. And this
you can still see the same texture, just on a smaller scale.
Yep, and this is one of those Mesosiderite C's. So this one doesn't have a petrology assigned to it. It just got grouped to C, so it's those
orthoproxine.
Yeah, and there's only 8 of these that are C's, and there's even fewer that are like C2 and C3.
Wow.
So I'm still on the hunt for those two, but you have to have favorites that you cut. So I've cut a couple Mesosiderites, and this one's my favorite, 14518. And because I started cutting it, and that saw blade ran into a dead stop.
Wow.
It sat at dead stop for quite a while.
That is unbelievable.
That is why. So that was one of my favorite cutting pieces. Then you're mentioning inclusions in there, and yeah, there are eucrite-like and some diagonite-like inclusions in Vaca Muerta. So that's Vaca Muerta that I cut up over there, and that's a bit of that eucritic-like material. Again, is it truly eucrite? I think just compositionally, it's close, you know, so that's what they're calling it. And that's a bit of, because we mentioned, you know, diagenetic material, which would be deeper mantle, does exist in there, and that is a little separated nugget.
Oh yeah, you can see through it.
Yeah, it's translucent, so it's a cool little nugget you can see through there.
That right there in your hand is an example of one of the class that are cut inside the Mesosiderite that we're seeing, like especially in when Art mentioned like the pebbles in his Vaca Muerta. That's what those, when they're talking pebbles, they're talking, you know, bits of eucrite-like or diagonite-like material. And then the final piece I got to show is this piece of Bondoc, which came out of the Walton collection. And before it came out of the Walton collection, it came out of Huss's second collection. So that is a second collection Huss number on the side, 684.203. Wow. Yeah, if you're gonna have pieces, you might as well make them special, right?
Yeah, those second collection Huss numbers are not overly common, so those are cool ones to go after.
No doubt.
That's all I got.
Wow, that's fantastic, buddy. I really appreciate that. Someone new to the clan joining us on camera. We got Mr. Ken Woston.
Hey,
how are you, buddy?
How's it going? I'm here just like a fly on a wall, but
glad to have you.
But this is a Nininger special. It's the Bondoc, and I got this from Mr. Vargas before.
Oh, nice.
And I noticed since I got the card here.
Oh, yep.
231 grams. And then it's like they used like a Rust-Oleum or something. It's like a paint, if you noticed. I guess that was one of the things on some of these specimens that they put. Maybe it had something to do with some of the water, that when he had the main mass, there was something, because I think it took like 4 years to get out of the Philippines. Wow. So, you know, maybe that had something to do with it. But I just wanted the historical fact of the Nininger. That's why I ended up securing this piece. Beautiful. So like a pride and joy.
Yeah, man. I don't have a Nininger piece in my collection. I don't yet. One of these days I'll get one, but I haven't found the right one and haven't been so motivated. That one's really weird, Ken. That paint on the outside is definitely an oddity.
Well, yeah, if you do some research on the Nininger thing, they did some brown paint on it.
I have one Mesosiderite that I want to show off, and I want to show it off for two reasons. It is a beautiful meteorite. It is a 1 of 1, and I also kind of want to rub it in Chris Colvin's face because he doesn't own it anymore. So this is the main mass to NWA 13532. It's a 1 of 1. It's the only B23 meteorite in existence, and it's an end cut. There you have it, folks.
Oh my! Oh, eye candy. Yep.
That nodule is calling my name. So I actually bought it from Chris while it was still under the classification process. He knew it was going to be subtyped, but we didn't know what it was going to come in at. And I bought it, and it turned out being a 1 of 1. So score 1 for Topher. Yeah.
Cool.
Roll the dice and 1.
Yep. But on this
and you
one,
want to rub it in his face?
Yeah, I'm going to rub it in his face.
You're so bad.
If you look at the outside of it, the outside really doesn't give you much insight as to what the inside's going to be, you know?
Yeah.
You do have this
metal nodule.
Yeah, the metal nodule right there. But as far as just the outside of a rock, no one's going to really, that's not going to really get my attention. But then to realize it's a 1 of 1 Mesosiderite is pretty darn cool. So That is the rarest Mesosiderite in my collection. And I lied. I do want to show off one other one. This shout out to Juana Vilas Poblar. It's a single stone end cut, and it's so beautiful. The metal in this.
Oh wow.
All of the nodules have texture. And this one up here is hanging on for its dear life.
Wow, look at that.
It's barely on it, but if you look at the exterior of this one, you can totally tell it's different than the other one, or maybe it's just more weathered, but really can't tell by the outside what you're getting on the inside.
Congratulations.
Thank you very much. Thank you so much for an amazing hangout. It was our first of the year, and hopefully we'll have many more to come. Thank you so much. See you guys next week. Bye-bye.
Good night, everybody.
Bye-bye.
Next week.
Good night.
Bye-bye.
Peace.